Hello, this is the first video in a series about projects Arena netcode, its client, server and model simulation on-site server. This model. What you see on a screen is a live recording of two separate builds, two people playing over the net from two different countries on two different operation systems, while the server runs on a third computer. And this is the profiler from that server. As you can see, we handle a fully authoritative simulation of one model in roughly a quarter of a millisecond. Remember, the same character takes roughly 1 to 1.5 milliseconds to process on the client. The server is fully authoritative and covers the entire simulation, with nothing cut. But to get from this to this, we need to say a lot of words about our server not being simply client's code launched with headless. Enjoy! Chapter 1. Frameworks denial. No supporting frameworks, libraries or add-ons were used to write projects Arena netcode, with the exception of ENet library bundled into Godot. Naturally, before I describe any concrete implementations, I have to explain and defend this choice, and to do that, we need to talk a little about frameworks in general, their advantages, disadvantages, and why my solutions tend to be in-house implementations. The first thing I need to mention is that I am a huge fan of DoD approach. No, not you. There is another DoD that people sadly tend to overlook. Domain-oriented design. Domain-oriented design is a philosophical and semantic approach to creating solutions centered on author's awareness that a solution is written for a specific domain problem in a specific field of knowledge. Abstractions invented while searching for a solution should, first and foremost, effectively answer the question of how to solve the problem within the domain if all the surrounding code worked perfectly, and only then answer how to breach domains and programming concepts in the broader sense. In a way, you could say that domain-oriented design is quotes OOP absolutized. Object-oriented programming focused on describing what happens in a program not just through entities meaningful to the execution, but through entities meaningful to solving the problem. And now, once we establish that we want our solution to be domain-oriented, two ideas collide at their very core. What's a framework? A framework is a huge set of ready solutions presented by its developers to its users under a contract. Any solution to your problem can be built out of these prefabricated bricks. The greatest problem with frameworks is that writing a generally powerful and extensive framework without deconstructing the domain beforehand is simply impossible. Think about it. You want to create every solution to every class of problems within some domain in advance for every future user. To do that, one way or another, you must make an enormous number of decisions on behalf of those future users about what their specific applications of your framework will look like. Deconstruct every possible future solution into clearly defined subtasks and divide every possible entity your users might need into a set of predetermined bricks. To see what I mean, let's look at an example. The Netfox add-on. I want to emphasize strongly. I am not trying to shit on Netfox, say that it's badly made, incorrectly made, or fails to perform its function. No, absolutely not. Netfox authors, if you are watching this, great job, this thing works far better than Godot's built-in multiplayer API. I just want to use it as a concrete illustration of my point, as if to say, darling, it's not you, it's me, we can never be together. Looking at Netfox, we can easily trace how the need to deconstruct the domain in advance leaves its authors practically no choice but to write classes such as property, property entry, property snapshot, and so on. They simply need those for the framework to function, there is no way around it. They can't write universal internal logic unless those concepts are strictly defined. But this automatically nails down the design of every Netfox user's solution. Listen mate, if you want this property synchronized, you have to register it here, and here. Otherwise, it won't run. Do you see the problem? By signing a contract with this devil, your project is no longer domain-oriented, it has to be framework-oriented instead. By the sheer fact of its existence, a framework sort of pierces your solution, vertically integrates itself, and dictates most life cycles, control flow, and data flow inside your code. It is the entry condition. And for myself, I am a real princess and a pea type, you know? I am a picky, independent and assertive partner, design-wise, obviously. I need to decide if penetration happens, and if it happens, I decide time, place, depth and pace. I will never let some third-party tool dictate in advance how I create my solutions, unless there is a very compelling reason to do so. This is why I don't use most add-ons and plugins such as Behave, Netfox or State Charts. I can write my own shit. Thanks. Chapter 2. Codebase Split. Now when we have agreed Project Arena's netcode must be written by me, I have to defend another potentially controversial decision. Project Arena Client and Project Arena Server are literally two different projects, in different folders, connected by absolutely nothing except their domain and the coincidental overlap of some scripts and resources. Naturally, I have to mention that this isn't the standard Godot approach. You can find forum threads claiming this is an intellectual masturbation that promises nothing but headache. There are entire specifically Godot talks about how wonderful it is to keep the client and server in a single project. This contradiction forces me to spend some time explaining my choice. As a preamble to my defense, let me remind you, this video is not from a tutorial series, but from a devlog series. It describes the fate of the project and documents the choices made. It is not a recommendation for action, nor does it claim my path is correct. Cheap argument number 0, just as an appetizer. The construct if server then something else client something makes me want to vomit. Even without touching the aesthetics beauty of the code, this construct forces the programmer to exist in 2 dimensions at once while writing a single function. And the moment we leave Mario scale projects and begin building something serious, this construct will appear about 100 times. By breaking this vicious cycle of self-deception and splitting our projects across the 2 codebases, we let our brain think about only one control flow at a time, while also saving several thousand lines of most hideous branching operator imaginable, one use of which turns dozens of lines into dead weight on a whole codebase. And of course, we shouldn't forget the elephant in the room, since our brain is thinking about one control flow at a time. The machine spirit blesses us with an ability to have fundamentally different control flows for 2 codebases. Real argument number 1. The goddamn project uses Godot engine. When you choose Godot, you need to feel the gun pressed against the back of your head. And written on its barrel are the words: every single player of your game had read every single line of your code. I do understand that this gun exists. I agree to work under these conditions, and I'm prepared to hand you, filthy cheaters and frauds, my beautiful client and the map of my messaging protocols to tear apart and analyze. Learn something useful, friends. But I would very much like to spare my server of the same fate. Obviously, the ultimate security guarantee must come from validation algorithms and all that, but why make a cheater's life easier by exposing the server's code, right? Project Arena aims to be a competent competitive game where cheating can make the difference between victory and defeat. This isn't a co-op game like It Takes Two and so on. Argument number 2. There is no symmetry between the client's lifecycle and the server's lifecycle. Not only Project Arena tries to be a competent game, Project Arena's server is trying to be a competent server, and being competent means serving more than one match for its clients at once. Let's run a thought experiment. Suppose we find ourselves in a hypothetical universe where we manage to simulate an entire room with 2 players in 1/100th of a millisecond. In that case, one server with one room costs its host machine that Godot overhead plus the cost of processing the room, in practice then just the Godot overhead. In such a universe, would it make sense to launch another instance of the server application for a second pair of players who wanted to play? Well, your answer is probably no. This leads to an important idea. We want a single Project Arena server application to be limited by the resources of the machine it runs on and to hold as many rooms full of players as that machine has the capacity to serve, but no more. And if that's the case, how do you imagine this project sharing a code base with the client? Well, it's feasible in theory, but the solution would be rather absurd. From the client's perspective, its game room is its whole life. From the server's perspective, that game room is one of many instances loading the CPU. Argument number 3. Our previous decisions rather naturally neutralize the apparent drawbacks often cited in favor of a single codebase. My project will not require extra effort to develop server logic separate from the client in another codebase merely because of the split. It already requires that by default. My project will never suffer from the difficulty of creating scene tree dependent mechanics across separate projects. It doesn't use them anyways. There is not a single RPC in my code, more on that later, and there is not a single synchronized entity anywhere in the entire project. In fact, the term synchronized entity itself is straight up forbidden, excluded from thinking frame, exiled from my brain, and this decision is fixed in text on line 2 of my project's documentation design bible. Thus, by welcoming every horrible downside of splitting the codebase with open arms, I get all their surprising benefits for free, and boy oh boy, those benefits are nice. However, some consequences of splitting the projects still need to be face-tanked. At the dumbest approximation, creating a separate project literally forces us to duplicate any shared code, scenes included. In a project that already contains about 10,000 lines, we obviously want to avoid this sad fate. The ideal imaginary workflow should be built around the ability to literally drag a piece of shared code from one folder to another with mouse, fix the necessary Godot UIDs for the transferred files, and continue working. Change the state machine on the client, test it in an offline room, automatically transfer the new code to the server, so the two halves of the simulation have identical models. However, such an approach imposes brutally strict standards on our scripts and scenes, primarily on the most important scene in our project, the characters model. This leads us, ladies and gentlemen, to Chapter 3, Codebase Agnostic Model.
能力が世界を制することはない。覇気だけが全てを凌駕する。大特権雷鳴発揮。
And at this point, instead of going straight into the refactorings I did, I would like to wander off into lyrical digressions and talk about the beauty and poetry of life. We have a fencing game. Here's our character. It has a visual model, rig, and a skeleton. The skeleton has several things utterly indispensable for the simulation. First, the skeleton has its ass, which is absolutely essential for pulling root velocity out of it. The skeleton also has a right hand, which is just as essential to the simulation because our sword is attached to it and we want to know the sword's global transform so we can hit our opponent. And finally, the skeleton has a spine, which, you guessed it, has a hurtbox attached to it, something we also need if we want to receive a hit from the opponent's sword. Knowing all that, would you call the skeleton an essential foundation of our model's simulation? Most likely yes. In most people's mental picture, even on split projects, a game room on the server looks like two characters identical to the client characters, while server time is saved by launching the project with the headless argument. But what if it isn't? Perhaps the entire structure of Project Arena server exists only because about a year ago a completely insane idea entered my mind: to remove character's skeleton from the equation completely. I am an extraordinarily ambitious son of a bitch. Once a crazy radical idea gets into my head, I have to spend at least some time trying to implement it, if anything, to test my abilities. And then something funny and poetic happened to me. Having built half of my Godot research quartz career searching for good solutions in skeletal animation, it seems I accidentally reached enlightenment so hard that my competence in skeletal animation accumulated critical mass, began bending space and started bleeding into every other part of my interest in Godot. Remember the story about this video, when I wanted an unusual skeleton modifier 3D that would use skeleton's bones global transforms instead of their local transforms. Remember how I solved that problem for myself? Yup. I stopped using animation and wrote my own data storage format, skeletal animation. Skeletal animation is a damn nice format. Given time as a function argument, it lets me access any bones global transform in O from 1. Back then, I used this insane property in a rather unremarkable way. I created a peculiar overlay animator. But you have probably guessed where this is going already, don't you? If we can name a point in time and retrieve the global transform of the hand holding our sword in O from 1, do we need a skeleton? The answer is no. Notice that ordinary animation resource can't afford this luxury. It would have to calculate the global pose by multiplying the pose matrices of every bone that comes before the hand. But I can. Well, if we agree that skeleton is unnecessary, it clearly has no place here inside the character's model. But fair fight, what are you going to do with your godlike custom-built skeleton modifier 3D animation framework? It needs a skeleton. Is the framework outside of the model now? But lots of code in your state machine states refers to it. Actually, I reply, this is a very, very good sign. We have reached a situation where two completely independent factors are pushing us toward the same solution from different directions. As I have already mentioned, we want the ability to literally drag any code from the client to the server. Here, for example, is some old code from my model, some random behavior from the state machine. If I send it to the server right now, where the animation framework doesn't exist, at least 10 lines here will turn red. On the client, letting the animation framework penetrate the FSM code this way is entirely justified and blameless. We gain flexibility beyond belief and pay nothing for it. But I already have 60 states. If I manually refactor every one of them to replace the lines that turn red on the server, I will lose my mind. If we inspect the model's old code, we will realize that, with a couple of exceptions, our model generally uses the animation framework in very similar ways, just with different settings. A natural course of action suggests itself. Let's give the animation framework a separate umbrella script, collect every possible call in there, expose only that umbrella script to the states, and call the framework internals directly from there. Then, we will be able to throw the states code onto the server without fearing red lines, and instead of 100 line states with 3 broken lines in each, I will have one umbrella script that is broken almost in its entirety. Yes, still plenty of red lines, but at least they are all in one place. Alright, now let's think, how could my lazy ass keep even this script from turning red when I drag it across? What will turn red in the first place? Well, everything related to the skeleton and any of its skeleton modifier 3D children. Too bad it's 90% of our new class. But there is one ray of light in this room of suffering. It seems our refactoring has revealed something important. This node, this class, is a model's logic layer. A layer it actually needs for simulation. This node is no different from things like combat or area awareness. A special, dedicated place you can visit and ask, how fast does my ass move? Or where exactly is my right hand right now? The domain role of a logic layer is to answer logic requests. To do that, it needs to know the logic of our skeleton modifier 3D code. Notice that not once have I mentioned the visual movement of my arse or the visual movement of my hand. Love the smell of refactoring in the mornings. Understanding what a skeleton modifier 3D should do and implementing those intentions are two different classes of action, which means at the very least two different methods, and at most different methods in two different classes. Drum roll, please. Allow me to introduce the newest participant in our carnival of madness, skeleton modifier logic. Yup. Heirs of this base class are the scripts attached to these unassuming grey nodes with suspiciously familiar names. And what about the skeleton, you ask? I cut it the fuck out and threw away. The skeleton now lives in presentation layer together with its sexy visual mesh. So how is our strong, independent and childless skeleton animated? Well, in fact, it has plenty of children. They just do not live with it full time and only come over on weekends. At runtime, in the models ready, we initialize the animation framework. If the framework has access to an injected skeleton reference, several children are initialized for that skeleton, one for each skeleton modifier logic. All these children are absolutely identical and have a single type, proxy modifier, a 7-line heir of skeleton modifier 3D. This modifier receives a reference to its logic donor and bends the skeleton's bones every frame in whatever way that logic donor deems necessary. Thus, on the client, the skeleton and its mesh merge in ecstasy and show the player their animated character. On the server, the animation framework never even receives an injected skeleton reference, so none of this happens, without preventing us from asking the animations what should be happening inside the model once in a while. The state machine doesn't care whenever the skeleton exists at all, it only needs answers to its questions. My character's servo model is effectively hypnotized, trapped in the infinite Tsukuyomi. It thinks it is animated. It can picture exactly how it's animated, down to the smallest details, but it never is truly animated. And my character model becomes codebase agnostic, receiving exactly 0 red lines when dragged directly between the projects. Purely as an unplanned secondary side effect, my server simulation time gets slightly lower after cutting the fat of about 4 times per 100 bones transform calculations per frame.
And no matter how tender, how exquisite, the lie will remain a lie.
A remote procedure call, most of the time, either is not remote or is not a call. By the laws of good anime, before this video ends, I have to introduce a mysterious scene about the grey eminence pulling the strings from the shadows. I'd like to lift the veil just a little. My previous chapters, where I listed arguments defending a particular choice for you, were pure theater for the external user. Like a true zealot, I pretend to the world that my religion has logical origins, lore and rational justification. The real reason is hidden from you. Internally, I make these decisions by following completely different principles. The thing is, my design is axiomatic. Remember how we signed up for domain-oriented design? Here is one of life's fundamental truths, friends. When searching for solutions to your domain problems, before your implementations can give you good answers, you need first to think very carefully and ask them the right questions. I hope the implementations in your projects are well documented, people. Mine certainly are. But my documentation contains another very important section, numbered 0, the documentation preamble. This section is a short list of in-house definitions for concepts that are not widespread in public sphere, a sort of glossary of terms I have permitted myself to use when writing documentation and more broadly when reflecting on my designs. The section also contains an unassuming and slightly boring area of numbered truths meant to describe the design of Project Arena as a whole in priority order. In a way, these are my own little tables of Moses. They give me a logical and ideological foundation for design and search for architectural solutions. They also help me to pull my head out of my ass once in a while if at some point I think I have found an architectural solution only to discover that it violates one or more of these points. You could say that one function of these self-imposed constraints is to provide a list of answers my design is forbidden to give. I think that it is really important for a project to have such sources of universal truths, a documented universal common ground of sorts. I would like to share some of the bullet points from there, numbers 2 to 6. Number 2. Participants in Project Arena network never assume that any code has been executed on another participant in the Project Arena network. Participants in Project Arena network cannot rely on the assumption that some code was executed on another network participant. If a participant in Project Arena network needs information about processes occurring on another machine, it must ask that participant a direct question and expect a direct answer, while also having a course of action for every possible answer to that question, including refusal to answer and no answer within a predefined timeout. Number 3. Project Arena's network design does not permit synchronized invariant entities that live simultaneously on the client and server as a single distributed object. The low and boundary layers of the network are protocol invariant. Client and server use one global protocol map and shared scripts for service abstractions, including packet route and protocol exchange. At the high level, invariance gives way to variant entity mappings. Semantically, such entities should be called projected entities. Using the term synchronized entity in reasoning, descriptions, or the semantic API design for Project Arena's domain logic is forbidden and violates the established laws of the design. Number 4. A variant entity mapping implies the existence of an authoritative server entity and 0, 1 or several client mappings of that entity. Each client mapping is an independent, deliberately altered projection of the server original, not a replica of its object, no tree, field set or FSM state. Server and client entities may have no common ancestor and may use different classes, states and internal algorithms. Number 5. A stable correspondence of domain processes exists between the server original and each client mapping. If a change to the server entity must become observable to the client, a paired high-level entity exists on the client to receive the result of that change and interpret it within its own domain model. This correspondence does not require identical states or actions. The server may run an internal multi-stage process represented to the client by a single resulting event. Number 6. The description of every pair of variant mappings must contain a correspondence table. The table lists the server process, the result transmitted over the network, the client mapping's reaction, their shared domain concepts, and the internal differences between their implementations. The table proves that two entities are different sides of the same phenomenon rather than two coincidentally similar classes. A pair of entities cannot be treated as a projected entity unless the documentation provides such a correspondence table for both participants in the projected entity contract. By declaring such a set of axiomatic truths for the project, I get a powerful tool to estimate my potential architectures against this fundamental base. I can check the pulse of my project. Does it sing in sync with my core principles? And if it does, the whole project is, well, based. Do you see the cyclical structure of the narrative? Now, after my axiomatic coming out, the opening chapters have a vibe of being ordained by fate. It doesn't matter what words I find to justify my reasons for rejecting ready-made networking solutions for Godot. The thing is, not a single one of them passed either the rejection of synchronized entities filter or the filter that forbids the very concept of remote procedure call. My project's rejection of this concept was decided in advance. The only networking invariant I permitted myself is the invariant communication protocol between network participants. It doesn't matter what words I find to justify my reasons for splitting the projects. My project's refusal to consider processes symmetrical was decided in advance. Processes are never symmetrical, they can only be analogous. The difference in control flow between client and server is not a convenience I might gain by splitting them. The difference in control flow is nailed down, laid in the foundation, carved into the stone table I brought down from the mountain. The decision to build a universal model for the client and server is not a consequence of wanting to drag scenes around with a mouse. It is a search for a sort of greatest common divisor, the creation of a brick that coincidentally overlaps between two different projects, is embedded in two different control flows, and produces the same output response for the same input. But under no circumstances do I think of such a model as of an attempt to create a unified synchronized character entity for the client and server. They are different entities. They simply need a very similar function called simulate, one that produces the same result, regardless of such factors as local time and so on. The difference between those entities emerges right after the boundaries of that method call. It is simply called from different places by objects with different class name definitions. They just share a model. And now, after the common ground set, we finally have a permission to look at the first code line. We will look at it in the next video about communication protocols. For now, I take my leave. Thanks for watching, and as always, know your heroes, folks. These wonderful people who supported the channel in its darkest times.
Very few indeed have come even this far. And yet your journey is far from over.